Over the past years, I've received a significant number of requests for further aid, not just from the comments, but also entrepreneurs, researchers, and companies. As a small YouTuber, it has shown me how direly the world needs more professionals in robotics, and I decided to continue uploading videos for the sake of greater education. I decided the first one I would upload would be the one that would end the series I began 2 years ago. In this video, I will show you how to control your drone to autonomously navigate, such as in this clip where it flies in an 8-figure. The steps I go over are important for facilitating further intelligent behavior and will signal the resolution our past videos headed for. In previous videos, I used a different drone, but I dismantled it for other projects. Instead, we're gonna use this guy over here with a RealSense tracking camera. If you followed my steps from previous videos, don't worry, because there is no difference between using the tracking camera and your own VIO solution. First thing we're gonna do is set up a Wi-Fi hotspot on our drone's computer. Press the plus button, choose a Wi-Fi connection, and we're in. We have a bunch of options here, first one being the connection name, which doesn't matter much, so we're just gonna call it hotspot. Then our SSID, which is how the drone will appear on the network. I decided my autonomous drone fits because that's the name of our project on GitHub. Then we choose the hotspot mode, our Wi-Fi device, and make up a password. Make sure IPv4 is set to share to other computers and you're set. When the onboard computer boots up, it'll automatically become a hotspot. This is my own PC, so I'm not gonna set it, but this method works on any computer running Ubuntu. Now we turn on our drone and connect to it via Wi-Fi, which in my case is named Jetson Drone, because it's equipped with the Jetson TX2. After we connect to it, we get a Wi-Fi address of 10.42.0.103 and SSH into the drone. In case you don't know what's your drone's Wi-Fi address, we can use Nmap to find it based on the address prefix our computer got after connecting. As you can see, Nmap found two addresses, one of which is our own and the other which is the Jetsons, noted by an NVIDIA MAC address. Notice how only the fourth number differs from our address to the Jetsons. Let's SSH back into the drone and get ready for flying. Ideally, we could use a single terminal, but for the sake of demonstration and safety, we're gonna need a lot more. We now launch the ROS node responsible for visual odometry. In my case, it's the RealSense node, but this step also applies to your own visual odometry node. Let's check the ROS topic to see everything's good. We're interested in the odometry topic, so let's echo that. Looks good to me. How about the frequency? Yep, we're set. Our next step would be to launch the PixHawk node that's responsible for MavROS. If you followed my previous videos, you should launch this node first since it triggers the camera for capturing images. Let's check the ROS topics again. I want to make sure PixHawk is properly communicating with the onboard computer, so I'm gonna echo the MavROS state topic. As you can see, the connected parameter is set to true, so our connection is live. The mode is also set to manual, indicating RC communication is online. In order to feed the visual data to PicSock, we need to relay the data to a special topic in Mavros, the Vision Pose topic. As you can see, currently it isn't publishing nor receiving data, which is as expected. I'm going to launch a node that will relay the visual tracking data to Mavros in addition to throttling it. There it is. Mavros is now getting data at 20 Hz, down from the 200 Hz we had earlier. If you have your own VIO solution, you can relay your publishing topic to the Vision Pose topic at a rate that's around 20 Hz. The last thing to do is launch the guidance node, which I'm going to show you now. This very simple piece of code, which I uploaded to my GitHub, will turn our drone autonomous. I'll command the drone to fly in an 8-figure using the magic of parametric equations, which will calculate the x and y position with relation to time. We initiate a variable I to 0 and then increment it every loop. Then we publish updated position commands to the setPoint topic. The if clause will keep the drone at a height of 1 meter above the ground for 30 seconds before starting the 8-figure. We now run the node as a test. When I switch to off-board mode on my RC remote, you can see change in Mavros as well, and it's no longer manually guided. This is only possible if Mavros is receiving position commands via the setPoint topic. I'm going to show you a safety procedure you need to follow when switching to autonomous mode, or else this will happen. Clearly, not ideal. When you first arm the drone and start in manual mode, you'll want to gradually transfer more control to the drone by going into altitude control mode to keep the drone at a constant height, and then into position control mode, which keeps the drone flying at a constant position without pilot input. Once more, manual, altitude control, and position control, and then to off-board. When you switch off off-board mode, Mavros will go back to the last mode you had. By doing this, you avoid having to take over control immediately, which is impossible and leads to a crash. For landing, you would then gradually go to manual mode. Thus, our DIY autonomous drone project comes to an end. I hope this tutorial series will get you up to basics so you can make more intricate and useful drone projects. So now I have a question for you. What should I do now? There are two directions. First, I could stay with drones and do tutorials on more complex topics such as 3D perception and planning. The second direction, which I think may be more exciting, is to branch out and explore other options, such as this wearable HUD. With this HUD, I wish to explore the possibilities of human-robot interaction by using my sensors, the HUD's processing, and the robot's abilities. Comment below what sounds cooler. Catch you soon!